Hey, how's it going, all? Just want to do another quick one. I want to talk about gravity's resume. And this is an incredible thing now that I'm watching a lot more of the debates and Nathan Oakley's channel in particular. Great dialogue. I've learned more in that debate show than all my physics courses in undergrad combined. And so, it's really good. They're talking about, very specific things and, making observations and debating ball earth people. But it's starting to get kind of sad, actually, for the ball earthers. Like, it's definitely, at least in that chat room or in that debate, it's, the vibration, and this is obviously coming from somebody who's a flat earther, but, you can really sense that, the ball earthers are coming in with just nothing. They're shooting blanks, and like, he's pinning them down to the scientific method, which is cause and effect, which really filters out all the hand waving heuristics, theoretical stuff, imagine this, imagine that. So gravity's resume, it would act on a body in all directions. So while we're talking about this, just think of like a ball earth, and then think of like a huge cargo ship or a tanker that is, upside down on the bottom of this ball and spinning as well. But just think of that in your head, what all the forces would be needed to keep that tanker, that heavy boat, against the water and able to allow it also, not just keep it there, but also allow it to move forward, with enough exertion on its part. But so gravity would be acting in all directions. It's not like in one direction, just pushing something like a little thumbtack against the ball. It would have to act in all directions around it, because the thing would just, even if it's being pushed against the earth, it would still have a desire to potentially, slip in other directions. It just can't be pinned to the earth. It needs freedom to be able to move and to be held against the ball. So gravity is actually not just a perpendicular force. It would have to be like a field, like a three-dimensional thing acting on the boat, just to use that as an example. And there would also be forces coming from out of the earth too. Like it would need to balance that boat up on the water in all directions. And so it's not just a perpendicular force. And even further compounded and reaffirmed by the fact that this ball apparently is spinning, rotating, and moving. So like the ball is spinning, it's rotating around the sun, and then it's moving, flying through the space. And so gravity would be the thing that is the catch-all to allow that to happen. And so another thing that ballers will have to cite when we talk about maintaining a vacuum next to a pressurized system, which is their explanation for how you can have stuff orbit the Earth, the gravity is used to defend that as well. It's basically a mysterious thing that gravity allows that vacuum to exist next to a pressurized system without having communication between the two to maintain them in isolation. And so gravity also, the amazing thing about it too is if you imagine that tanker moving around the ball, it's gravity would adapt, as the thing is moving. It's like if you imagine it at the bottom and then all of a sudden, the boat is on the very top of the ball, gravity could sort of relax for a moment, because now the natural weight of the boat is is holding it itself there. So gravity wouldn't need to be as forceful as it would if it were on the bottom, for example, holding, the boat onto the ball. And so it would have to have this kind of, locational dependence as well, wherever these objects are on the ball. Another incredible thing, it's the explanation for how it keeps these large bodies suspended in space. And so, obviously even on the flat Earth side, we don't have, all the answers as to how could a flat Earth with a dome be suspended in space. That's a miracle by whoever created it. But, for gravity to now also have on its resume the ability to keep these large bodies suspended in space and, maintain this orbit and also moving through space, that's an incredibly powerful thing. And so, Gravity's got a pretty, just from these 5 points right here, pretty extensive resume. And I just was just driving back. I was playing golf after work, and I was just looking at the Houston skyline, and just thinking in my mind, how did I ever think that we're spinning? Like, it's absolutely ludicrous. I don't know what is more insane, is the spinning or the ball, but I think it's the spinning for me now, because you just have to look at like a bunch of large buildings together, or just look outside and just think that, like, how could those things be spinning, and not just spinning, but at the speed that they claim, the earth is moving. It's outlandish. And so the curvature thing is also a major thing. Just, you need a couple seconds to think about the fact that there would have to be buildings and people and boats and stuff upside down, suspended, up, or like, kept together against this ball with this force called gravity, and that's outlandish. But, so just, the more you think about the things that gravity has to do, in order for gravity to be real, it would have to be the supernatural of all supernatural forces. And in many ways, the ball earth would reaffirm God's creation even stronger than a flat earth with a dome, which to me is blatantly obvious. It's like a stage, it's enclosure. But, for a force to be able to do these kind of things, it would have to be supernatural. But we know that it can't be done. If this were to be true, this would be some of the most amazing stuff that we would be able to photograph and see and understand and play with and interact with and brag about, that this was true, that this force exists, and we would be able to interact with it, and do experiments, and just another sort of thought experiment that I do, is just imagine like taking an apple and, gouging out a little piece of it and then putting like a few droplets of water in there. You have to imagine that if you were to like have like a way to inflate that apple bigger and bigger, let's just think about this just as a thought experiment. The logic of the ball earthers is that if you blow that apple big enough, eventually the water that you just placed in that little gouge would just stay there. Like gravity would then, the switch would turn on. If that apple was big enough, that water would stay there, and obviously it won't if you just have an apple and you take a piece out of it and you fill it with water. It'll just drip off the side. But in this thought experiment, that water would stay there if you could blow the apple up to I guess at least the size of the earth. And so, that's preposterous. Another thing I wanted to mention too quickly on the ball earth is that, I worked in seismic. I worked for Western Geco, a company owned by Schlumberger, and I did seismic, and just, again, I wasn't like, didn't know everything about seismic. I didn't work there for like decades and stuff, but I do not remember a single person mentioning correction for curvature when we were, doing processing on the data. And so this is imaging the subsurface, and, it's done over, many miles. So the curvature one would think would be relevant to the survey and to the processing, but no mention of it. And so I started looking into it, and it looks like there are research papers that address it, and they make certain assumptions that, it can be deemed flat for, a certain length, and it only matters in specific, acquisitions and processing. So, that to me is really strange, that it was not even mentioned once, in the few years that I was doing that. So, I just throw that out there as an FYI.